Okay, equations of the form x squared equals k. Okay, so this is a topic from like Algebra 1 / Algebra 2 days. It's just a little refresher. When you're solving an equation like this is a very basic form of it. You can see up here in blue it says if x squared is equal k, so x squared equals some number, and you have a few different outcomes. If x is 0, then k is 0, and that's good. If not, if x isn't 0, therefore x would equal plus or minus the square root of k, as long as k is greater than 0. If k is less than 0, you would have an imaginary number. And that's why that says this line right down here. And we'll do a little we'll talk about that right below. So here we're going to solve this x squared equals 4. So as a reminder of your Algebra 2 days, to solve something like this, you would square root both sides of an equation. The square and the square root are inverses, so they would cancel each other out, leaving just the x. And then you would have the square root of 4. Now when you square root both sides of an equation, you do need to include the plus and minus sign, hence why you see this up here. And the square root of 4 is 2. And as a reminder, why we need plus and minus, if we go back to the original problem, x squared equals 4, 2 squared is 4, and negative 2 squared is 4. So both of these are true statements if we plug them back in. That's why we need our plus and minus. Now, on the one on the right, we have x squared equals negative 4. So if I square root both sides of the equation, and the x and the square and the square root cancel out, we have x equals. Now here we have a negative 4, which means we're still going to get our plus and minus from squaring both sides, but since we have a negative there, we have to realize that this doesn't work in a traditional sense. We have to remember that if there's a negative inside, we need to include the letter I, which is referring to imaginary, a non-real answer, and then the square root of 4 is just 2. So these can happen, but you just have to remember this is not a real number. This is an imaginary number. All right, so let's look at some ones where they're just a little bigger. So we want to solve for x. So our goal is to isolate x. So we have 3x squared minus 1 equals 8. So if you can, do any addition or subtraction first in the problem. So we're going to take this minus 1 and we are going to add it to both sides. These would cancel out, giving us 3x squared equals 8 plus 1 is 9. Then you want to do any multiplication / division. So this is 3 times x squared. So the opposite of times is divide. So we divide both sides. So we have x squared equals 3, because 9 divided by 3 is 3. And now we can go ahead and square root both sides of our equation. So x will equal, don't forget your plus and minus, the square root of 3. And you're done. The one on the right, same idea. We want to start off with any addition or subtraction first. Be careful when you see this right here. That negative 2 that we see, minus 2, that is being times the x squared. So we will not start there. We're going to start with the 5. And we are going to have, this is a positive 5, because remember, symbols are in front. We're going to minus the 5 over. We're going to get negative 2x squared equals 6. We're then going to divide both sides by negative 2, because this is negative 2 times x squared. Those are going to divide away, leaving x squared equals negative 3. Then we're going to square root both sides, and we are going to end up with x equals plus and minus. We do have a negative inside of the square root. That means we need the letter I. And then since we can't square root 3 and get a whole number, we're going to leave it inside the square root. So it'll be plus and minus I square root 3. All right, so for this one, still solving for x, but this time everything's inside the parentheses with the square being outside the parentheses, which means we actually have to start there. There's no addition or subtraction outside of the parentheses. So we're going to start inside. We're going to start with getting rid of the parentheses. Since the parentheses have the square, we're going to do its opposite, which is square rooting. So the square root and square can cancel each other out, leaving us x plus 3 equals the square root of 36 is plus and minus 6. Then we want to get the x by itself, so we're going to minus 3. That's going to subtract away. So we will have x equals negative 3 plus and minus 6. So we have two answers here. one where it's minus 3 plus 6, and one where it's minus 3 minus 6. That's going to give us negative 9 and positive 3. So there are our two answers. All right, our second one's doing the same thing. Since there's nothing outside the parentheses, you want to start with that. And since it has a square on the parentheses, that stuff's trapped inside, so we're going to get rid of the square. So we're going to have x minus 4 equals plus and minus the square root of 7. We can't really square root 7 and get a whole number, so we're going to leave it like that. Then we're going to add 4 over. So we have x equals 4 plus and minus the square root of 7. So we technically have two answers. X equals 4 plus the square root of 7. Oops, 7, if I can write that correctly. And then x equals 4 minus the square root of 7. And so then here are our two answers. All right, our last set of problems. They're very similar to the ones we kind of just did. Once again, we have x plus the square root of 3 inside parentheses with a square. We want to get rid of the square first. So we're going to square root both sides. The square and the square root will cancel out. So we will have x plus the square root of 3 equals plus and minus, because once again you square rooted both sides. The square root of 4 is 2. Then we're going to go ahead and minus the square root of 3 over. So we are going to have x equals negative square root of 3 plus and minus 2. And we could write this to make it look a little neater. X equals 2 minus the square root of 3, and x equals negative 2 minus the square root of 3. Often when answers are written, the radicals are behind our integers. All right, our last problem. Here we're going to go ahead and get rid of the square by square rooting. We're going to have 3x minus the square root of 5 equals plus and minus the square root of 2. We are going to add the square root of 5 over. So we're going to have 3x equals square root 5 plus and minus square root 2. And we're going to divide both sides by 3. So we are going to be left with the answer x equals the square root of 5 plus and minus the square root of 2 over 3. And there's nothing else you can do to that problem unless you want to get the decimal, which is not necessary.